So, if you remember, we picked out 100 cells that showed up with high internal resistance readings on the Opus PTC 3100, and we earmarked them for the bin. But the thing is, I took the decision to split them into 16s and lose a few and add a few more in, because we lost a few because of the voltage was actually dropping. Some were down to 3 volts already, some were sort of 3.7. So we binned a few and we added a few from the moderate to good cells that I had laying around. And what we've done is we've got 7 lots of 16, which we split into 4s. I've used Repacker to split the 94 odd cells into 16s and then the 16s into 4s to get balanced packs. Now, before I get flamed, we were looking at around 25 amp hours for 16 cells, which is bad. But between the packs of 6s, we've got about 6.1 to 6.25 amp hours per 4 cells in a string. And what we've done is we've used the 5 amp fuse wire on the top, and we've used thin gauge solar tabbing wire on the end, on the negative end. And I waited until my batteries were at 4.1 volts fully charged before I went like this, inserting the positive first to avoid damaging the top end, and then slotting the negative in. Now, the reason why I've done this, and I'll probably get some thumbs down for this, but I want to see a failure. I want to see what happens when a cell goes bad. It's all well and good putting hundreds of good cells in, but what happens when a cell goes bad? I want to see if one of these fuse wires sort of activates, well, not activates, burns out. But I also want to see the fault finding aspect. Obviously, using a sort of, what's that noise? Not me. Using a wall such as this with the holders going up and down, it's fairly easy to fault find. Obviously, you take hold of, say, this set here has a bad cell. We'll start with the ones that are more suspect, so we'll remove these and test these. And then further from that, we can split them down into the 4s, into individuals. So I want to see how long these bad cells will run for before we get a problem. Now, maths being maths, I've just rounded it down, but we're looking at around 600 watt hours for the 16 by 7, 16 parallel 7 series, whereas before we would have had 200 watt hours. So we've increased the capacity on that set of 4 cell holders by 400 watts, I think. I can't remember now, but that's just the rough maths. So what we're going to do now is, obviously, we'll probably be drawing down some power overnight. But what I'm going to do is set something up to run during the day to capitalise on the capacity, and I'll be monitoring this. Well, I'll be honest, when I'm using it, if I come over from work, I come in, I check, see what's gone in, what's gone out, check the cell balances, and then I'll go and do what I've got to do. And then before I go to bed, I'll come and check again. And then when it comes to the morning, I'll come back into the shed, and then I'll check it, and then set something up to charge during the day. So regardless of having a super duper charge controller, I want to monitor it. I want to see everything that's going on. So I'm quite happy to install bad cells into this, because I want to see what happens when it goes wrong. I want to see, come back and see one set of cells is lagging behind the others. So what I'm going to do is I might turn off the balancing function on this, because I don't want to upset it, and we'll go from there. So hopefully tomorrow I'm going to do another timed video, not time lapse. I'm going to try and get this going, where we're going to be pulling some quite high currents, and see what happens. If the shed burns down, it burns down, right? Nah, well, probably won't get that bad, hopefully. So yeah, that's where we got to. We've added 16 cells in the place of 4 bad cells, but 6 amp hour packs. So I'm hoping it probably will stay in balance. But we'll come to that in another video, I guess, when it goes bad. So yeah, thank you very much for watching. Please subscribe, comment, rate. I'll see you in my next video. Cheers.